All right, so what I want to do now, so I've roughly drawn up what you've got on your periodic table, I'm going to go through each of them, and what we're really interested in doing is identifying patterns and trends. So over here we had hydrogen. I'm not going to write names, but I'm just going to draw our... So we've got one electron, and that's got an electron configuration of 1. Next one over here is helium. Helium has 2 electrons and has an electron configuration of 2. So hydrogen and helium are a little bit odd in some respects because they only have 1 shell, and that shell can only have 2 electrons. The trends that we want to observe really start coming in when we go to the next one, which is lithium. And we have 2 shells for lithium and 1 electron in the outer shell. So beryllium is next. 2 electrons and 2 electrons. Beryllium, then boron. 2 electrons and then 3 electrons. So we are in period 1, period 2, period 3, period 4, and we're in group 1, group 2, group 13, group 14, and so on. So, what do we notice? Oh, so I should be putting in 2, 1, 2, 2, 2, 3. What do we notice in terms of trends in what we've done so far? Yeah.
The first shell always has 2.
The first shell in this period always has 2. Yep, excellent. What else?
So the group number equals the number of atoms in the outer shell, except for the 13, 14. So those obviously have to minus 10. For example, 0, 1, 2, and count 30 is 3 and 40 is 4. And that equals the number of atoms in the outer shell.
Electrons in the outer shell.
Electrons, sorry.
Yep. So the number of electrons in the outer shell is equal to the group number, or the group number minus 10 when we go to 13. So here we have 2 electrons in the outer shell, group 2. Here 3 electrons in the outer shell, group 13. So carbon is next. We have 2 on our inner shell, and then on our next shell, our outer shell, we have 4. We're in group 14. Okay, excellent. What else have we noticed? Yep. The electrons go in pairs, yep. So we try and pair up the electrons. The other thing that we... so this should be 2, 4. The other thing that we can see is that we're in period 2 and we have 2 electron shells. So how many electron shells would these ones have? Period 3 would have 3 electron shells. So if we follow our pattern, then we should be able to randomly select an element. Let's choose this one here. What period is it in? 3. So how many electron shells does it have? 3. So we know the first shell is going to have 2. The second shell will have 8. So how many will we put in the third shell? 6, because it's in group 16. So we can work out how many electrons it has, can't we? We've got 2 plus 8 is 10 plus 6 is 16. So the electron configuration here is 2, 8, 6. It's got 16 electrons, so it must have 16 protons. So its atomic number must be 16, so it must be sulfur. Okay? See how we work backwards there? Just by knowing its position on the periodic table, we can work out its atomic number. We can work out the number of electrons it has. We can work out the number of shells it has. We can work out the number of electrons it has in its outer shell. So what about this one here? How many shells do we need? How many are going to be in the first shell? How many are going to be in the second shell? 7, because we are in group 17. So we've got an electron configuration of 2, 7. And 2, 7 is 9. 9 electrons, 9 protons, so we must be fluorine. Okay? So let's go over here and see if it still works. This one here, how many electron shells do we need? 4, because we're in period 4. So how many electrons are going to be in the first shell? In the second shell will be 8. How many in the third shell? 8. And how many in the fourth shell? Why 2? 2 because we're in group 2. Yep. So if we count those up, we get 20 electrons. 20 electrons, 20 protons, atomic number of 20, so we must be with calcium.
177.
So this is calcium. It's got an electron configuration of 2, 8, 8, 2. Okay, so the observations that we should be making here are twofold. One, the period number tells you how many electron shells it has. The group number tells you how many electrons it has in its outer shell. Okay, from that piece of information you can draw the electron configuration. You don't need to count up the number of electrons to do that. You just fill the inner shells and then put the relevant number of electrons in the outer shell. Okay? So that is important for a variety of reasons, and being able to understand the number of electrons in the outer shell will help you when we deal with ion formation and the valency or the charge that an atom has, which is what we're going to move on to now, which we're going to talk about ions. So